Welcome to FAULHABER Drive Time. In this video we will go more into technical details of the linear motors. A linear motor works with the same principle of a brushless motor in the picture, where the interaction between the magnetic field generated by the three-phase winding interacts with the one generated by the magnets, resulting in a rotary torque proportional to the motor current. In linear motors, the three-phase winding is linearized and the magnets are unrolled and placed in a non-magnetic stainless steel tube. In this way, the interaction of the two magnetic fields generates a linear force proportional to the winding current value, responsible for the linear movement. Thanks to the non-magnetic stator, there is no detent force due to the magnetic attraction between the parts, so there's no vibration even at low speed. Three analog oil sensors are used to detect the magnetic rod position, and the two auto-lubricant bearings ensure a long motor lifetime when properly used. The analog oil sensors provide three sinusoidal signals whose period corresponds to a defined displacement of the magnetic rod. This is called magnetic pitch. For the LM1247, this is 18 mm. Different motor size with a different magnet inside the rod may have a different magnetic pitch length. The motion controller calculates the rod position, measuring the three analog oil sensor amplitude, and perform the appropriate commutation to provide the required positioning. The new generation of motion control series is able to divide this magnetic pitch in 4096 different counts, similarly to have an encoder with 1024 lines per magnetic pitch. The datasheet contains the main motor information. All the values are related to the ambient temperature of 22 degrees. The continuous force or thermal limit is shown also on the first line. The value is related to a thermal resistance of the housing, reduced by 55%. What is the thermal resistance? The thermal resistance of the housing is the resistance against the heat exchange between the housing and the ambient. And the 55% reduction is possible when the motor is mounted on a metallic surface, when it can better dissipate the heat generated by the winding. The peak force is related to an intermittent operation with 10% of duty cycle and maximum operation time of 1 second, when the winding reaches the thermal limits. Then the information of continuous and peak current are shown here. Those values are related to the force constant. The motor winding resistance from phase to phase and the related inductance are important values in case you need to design your own drive electronics. The thermal data are shown here. Thermal resistance and the thermal time constant are related to the winding to housing and to the housing to ambient interface. Please note that the winding heats up much faster than the housing, so we don't recommend to place a thermal sensor on the motor housing to estimate the winding temperature. This is because the winding may reach 125 degrees in short time, so it may already exceed the critical value when the housing is still warming. The magnetic pitch value is related to the magnet size used inside the motor rod. We have seen before how the rod movement is related to the period of the magnetic pitch. Other information like bearing and housing material are also included here. The stroke length depends on the number of magnets inside the rod. It's possible to have customized stroke values on request. All the standard stroke length with the corresponding rod length and the mass are shown in this datasheet section. For each stroke length is published the repeatability, positioning difference measured during the repetition of the same movement for several times, and the accuracy, a region of positioning around the target position. Then, the no-load values of acceleration and speed are shown for each stroke length. The acceleration is the ratio between the maximum force and the corresponding rod mass, while the speed is calculated considering a triangular speed profile and the maximum stroke length. The motor characteristic curve shows the relationship between the load and the speed, and the external force versus speed for horizontal operation with 20 mm stroke. The load-to-speed curve in black shows possible maximum speed achievable with a defined load applied with the road included. The three blue curves show the external force that can be applied with three different loads. The technical drawings with the measures and tolerances are shown in this section. Please note the maximum screw dip for correct installation. Take care about the screw material when you are mounting the motor. Because of strong magnetic field and its positioning speed capabilities, the linear motors must be installed with no magnetic material like brass or no magnetic steel, otherwise the eddy current induced on the mounting surface may affect the motor performance. Then the information on option with connector type and motor pinout for the correct installation with a motion controller are shown here. The last information is related to the combination with suitable FAULHABER motion controllers. Make sure to get the latest datasheet published on the product page on the FAULHABER website. So now you know how the FAULHABER linear motor work with their main characteristics, their sensor output signal related to the magnetic pitch, how the motion controller uses the sensor signal, and the main datasheet value related to the linear motor for a correct use with motion controllers. Thank you for watching this video. Check out for our other video on the FAULHABER drive time. Feel free to leave a comment here below. Take care, goodbye!